Hello everyone, welcome to my channel Biochemistry Concepts. This video is about oxygen dissociation curve. What is oxygen dissociation curve? Measuring the ability of hemoglobin to bind with oxygen at different partial pressures of oxygen by graphic representation is known as oxygen hemoglobin dissociation curve, or the curve which shows the ability of hemoglobin to load and unload oxygen at physiological partial pressure of oxygen is known as oxygen dissociation curve. The important point to be noted is when oxygen binds to hemoglobin, we can say that hemoglobin is oxygenated, but it does not mean that hemoglobin is oxidized. So there is difference between oxygenation of hemoglobin and oxidation of hemoglobin. Normal hemoglobin in the healthy adults is approximately 15 grams per deciliter. Each gram of hemoglobin can carry 1.34 ml of oxygen. So with 15 grams of hemoglobin per deciliter, it can carry 20 ml of oxygen per 100 ml of blood. In the pulmonary alveoli, hemoglobin is 97% saturated with oxygen. This is because of high partial pressure of oxygen in the alveoli, that is 100 millimeters of mercury. Whereas in the capillaries of tissues, the partial pressure of oxygen is only 40 millimeters of mercury. So here hemoglobin is 60% saturated with oxygen. So 40% of oxygen is released in the tissues. The oxygen dissociation curve for myoglobin and hemoglobin are different. The ODC curve for myoglobin has a hyperbolic shape. This is because myoglobin reversibly binds a single molecule of oxygen. Oxygenated and deoxygenated myoglobin exists in a simple equilibrium. So that is myoglobin plus oxygen, that is oxygenated myoglobin. So this is a reversible reaction. When oxygen is added, the equilibrium shifts to right. When oxygen is removed, equilibrium shifts to left. Myoglobin is designed to bind oxygen and to store the oxygen. So it acts as a reservoir of oxygen. This myoglobin releases oxygen within the cells in response to oxygen demand. The shape of oxygen dissociation curve for hemoglobin is sigmoidal. This sigmoidal curve of hemoglobin is because of cooperative binding of oxygen. What is cooperative binding of oxygen? Binding of an oxygen molecule at one heme group increases the oxygen affinity of remaining heme groups in the same hemoglobin molecule. This effect is known as cooperativity. It is more difficult for the first oxygen molecule to bind hemoglobin, but once it binds, the subsequent binding of oxygen occurs with high affinity. The affinity of hemoglobin for lost oxygen bound is approximately 300 times greater than its affinity for the first oxygen bound. Sigmoid shape indicates that the affinity of hemoglobin for binding the first molecule of oxygen is very low, but subsequent oxygen molecules are bound with very high affinity, accounting for the steeply rising portion of the S-shaped curve. The oxygen dissociation curve of myoglobin and hemoglobin, they show important differences. So this graph shows that myoglobin has higher oxygen affinity at all partial pressures of oxygen values than hemoglobin. The partial pressure of oxygen needed to achieve half saturation of the binding sites, that is P50, is approximately 1 millimeters of mercury for myoglobin and 26 millimeters of mercury for hemoglobin. The higher the oxygen affinity, that is the oxygen binding more tightly to the hemoglobin, the lower is the P50. There are different factors that affect the oxygen dissociation curve. Those are heme-heme interaction, carbon dioxide, carbon monoxide, 2,3-bisphosphoglycerate, effect of temperature and Bohr effect.